Boy, oh boy, do I have a cool formula for y'all today. So I recently learned about the Shoelace Formula. It's a formula that calculates the area of a simple polygon if you know the coordinates of its vertices. And I want to show y'all an example of it in action today. And the reason why it's called the Shoelace Formula is because the manner of our calculations will resemble how you would normally thread a shoelace through a shoe. You'll see what I mean in a moment. But first, let's remind ourselves of what a simple polygon is. A simple polygon is just a polygon that has no holes and it does not self-intersect. Also, we want to remind ourselves of how to evaluate a 2x2 determinant. To do so, recall that we simply subtract the diagonal products, AD minus BC, in other words. All right, let's take a look at this quadrilateral ABCD, and let's try to find its area, shall we? First, we have to order the vertices in a sequence that has a positive orientation, or a counterclockwise orientation. What that basically just means is that if you were to walk along the boundary of your polygon itself, the interior of the polygon, the area of the polygon, will always be on your left. Once we've done that, we're going to put the first point in our sequence, in this case point A, into our first determinant. And you can put these points into either the rows or columns of your determinants. It doesn't affect the calculations. I personally like to put them into the columns. So if we put point A's coordinates into the first column, the first determinant, it's going to look like that. And then we're going to follow that up with the next point in our sequence, point B. That goes into the second column of your first determinant, and that completes the first determinant. So notice how we started with point A in the first column and ended with point B in the second column, because now we're going to start with point B in the second determinant and end with point C. And in the third determinant, we're going to start with point C and end with point D. And in the final determinant, we're going to start at point D and end at point A, actually. So we essentially close the loop. And now we just evaluate each determinant. And notice in doing so, all these multiplications together seem to resemble the weave pattern of a shoelace in a shoe. Now we just add up the values of all these determinants, and in this case we get 46. But that actually equals to twice the area of your polygon, the quadrilateral. So dividing 46 by 2, we're going to get 23, which is the area of this quadrilateral. Now we can actually confirm our result by decomposing our quadrilateral into the following triangles and rectangle, and we can see that indeed the area works out to be 23 in this manner as well. Pretty cool, right? I think so. Perhaps you agree as well. Now, I actually read that the shoelace formula is actually used in surveying and forestry, so if you're employed in those industries, please let me know in the comments if you actually use this formula in your day-to-day work. With that, I hope you're doing well. Make sure to hit that follow button for more math content, and as always, I'll catch y'all in the next one. Take care.